In this video, we first introduce Newton's laws, then examine Newton's first law in its entirety, with many examples. The examples are practical. Please subscribe us to be informed about our new videos. Please see the video to the end to understand all its concepts. Newton's laws. Dynamics cannot be studied without Newton's laws. Newton's laws are very important, and have many applications in our daily lives. Of course, for very high speeds near to the speed of light, we need relativistic mechanics. And for very small particles like molecules and smaller, we need quantum mechanics. We do not need to get into these two issues at the moment. But, later when we start with modern physics, we will look at these two issues as well. We are currently examining Newton mechanics, which is very important. Newtonian mechanics has three basic laws. If we understand these three laws well, we can solve many physics problems. These laws made human know space, sea, mountain, and so on better.
Newton's first law. If no force is applied to the body, or the resultant force is zero, if it is stationary, it remains stationary, and if it is moving, it continue moving at a constant speed on the straight line forever. Note: there are four main cases in first law. Case 1. If the body is stationary, and no force is applied to it, then the body remains stationary. Case 2. If the body is stationary, and the result of the forces is zero, then the body remains stationary. Case 3. If the object is moving, and no force is applied to it, in this case the object continues to move in a straight line. Case 4. If the object is moving, and the result of the forces acting on it is zero. In this case, the object continues to move in a straight line.
Tip 1. If the conditions of Newton's first law are met, the motion of the body is without acceleration. Tip 2. The tendency of objects to stay at rest, or move on the straight line at a constant speed, is called inertia. For this reason, Newton's first law is also called the law of inertia. Tip 3. In Newton's first law, there is no difference between objects that are stationary and objects that move at a constant speed on the straight line. Tip 4. There is no difference between the following two cases. Do not apply force to the object, or the result of the forces is zero.
Example: a spacecraft is moving in space at a speed of 50 meters per second. An object is detached from it. Which path do you think is correct? Answer: because the spacecraft moves in a vacuum, no force is applied to it by other objects. So when the object comes off, according to Newton's first law, it moves at the same speed on the straight line. So D is correct. A can be correct when the spacecraft is stationary in empty space. B is true when the object is stationary first, and then released. C above ground surface can be true, because gravity pulls the object toward Earth.
Example: a car moves on a cliff. According to Newton's first law, it must move in a straight line, but this does not happen. Is Newton's first law incorrect in this case? Answer: no, Newton's first law says that, if no force is applied, the object will move in a straight line. In this part, two forces are applied to the body. One is the force of gravity, which we showed in red, and the other is the force that is applied to the body, from the surface of the cliff. The magnitude of this force is equal to the force of gravity, and opposite it, therefore cancels it, so that no net force is applied to the object, and the car moves in a straight line. This force is due to Newton's third law, which we will explain as soon as. But in this part, the car has no contact with the surface, so the only force entering the body is the force of gravity, that is, net force enters the body, and changes its direction.
Example. A driver puts a box on the roof of the car, and forgets to fasten it. Predict the movement of the box in the following cases. A. The car starts moving. Answer. The box is stationary, and tends to be stationary. When the car starts to move, the box drops due to the force of gravity. B. The car brakes. Answer. The box is moving, and tends to keep moving on the straight line. When the car brakes, the box is thrown forward. C. Car turns around the road. Answer. The box is moving, and tends to keep moving on the straight line. The box is thrown out of the field, when the car goes around the road. D. The movement of the Earth around the Sun. Answer. The Earth is moving, and tends to continue moving in a straight line, but the force of the Sun's gravity causes the Earth to move in a circular path. E. Moving a soccer ball. Answer. The ball is moving, and tends to move on the straight line, but the force of gravity causes the ball to move on a curved path.
Example. Why on icy ground, cars usually deviate off-road when crossing a curve? Answer. I think, given the previous examples, you know the answer to this question. Note that Newton's first law applies when no force is applied. What happens if force is applied to the body? This topic is very important and has many applications in solving problems. At this point we have to apply Newton's second law. We will do this in the next part. Please subscribe us to be informed about our new videos.